started here. All right. So hopefully you guys have been on DesignSafe, you've logged in, you've played around with it a little bit, and you have a basic understanding of what DesignSafe's about and what we're trying to achieve. So the vision of DesignSafe is we're creating a cyber infrastructure we want it to be an integral part of your research. So you're going to be using this cloud-based resource to do your research work on. You'll be able to do your analysis, your visualization, integrating all your data types and load it into one place. That's an important one we're trying to hit, the diverse data types. We don't want to pigeonhole your data into a certain format or into a certain style or into a certain data model that may not be applicable to your work. So we are essentially opening it up to all data types, all data files. You can load it into DesignSafe and use it as you go. And what we really want to do is support the end-to-end research cycle. So we want DesignSafe to be from conception to publication, back to conception, back to publication, and have that iterative process be part of your research cycle and your workflow. And of course, what we want to do is enhance, amplify, and link the capabilities of other NHERI components, and essentially the community that they support. So, very good. All right, so this is the plan on how DesignSafe is built, how we're planning on integrating the research in. I'm going to go ahead and magnify this window a bit. So we have essentially 3 centers outside of DesignSafe. We have the simulation research, experimental research, and our rapid research. These are all places outside who are generating data models, and we're going to be bringing those into the cyber infrastructure, into what we're calling our data depot. The data depot is where you're going to be able to store all your files, be able to store some of your scripts. Is basically just a big file manager, and it's based the same way. You can share out, you can collaborate. And the idea is from there, it is linked directly to our discovery workspace. And the discovery workspace is where we have our data analysis and visualization tools. We have other application and scripts that other people have written that you can launch and execute and run your data analysis and view your data. And then, of course, the data depot, once you have all your work set up, you have all your projects going, you have a team of collaborators, we want to be able to curate that data and then publish that data. And once published, you'll get a DOI on that, and then that DOI links back to that published information that's being hosted on DesignSafe. So that's our goal, that's our plan, and we are making big strides in completing that. All right, so this is what the plan is for today. One of the sides that we have that we decide that DesignSafe really needs is a way of communicating, a way of sharing files, a way of sharing links, and a way to basically bring the community a little tighter together. So here at TAC, we use a software application called Slack. You guys may have heard of it. You may have seen some advertisements on TV regarding it. And it's actually a really cool little application, and it does a whole lot more than just being able to communicate. So we're going to introduce Slack for a little bit. We're going to introduce the Jupyter Notebook, just some brief ideas of what it does, how it's used. And then we're going to focus in on Python, on the Python kernel on Jupyter. And then we're going to look at Numpy, which is a numerical library, a numerical and scientific library for Python. We're going to look at Pandas, which essentially open up a whole new way of doing manipulating data. We're going to look at some animation we're going to look at Matplotlib briefly, and then we're going to look at some animation techniques that you can use with Matplotlib. And then I came across a library called MPLD3. So D3 is data-driven documents, and the idea is to be able to bring some interactivity to your graphs. So we'll just look at a couple demos in MPLD3. And then one thing that a lot of people have asked for is, all right, DesignSafe has all these applications. How do I use Jupyter to be able to launch those applications? So we will be touching upon that as well. All right, first thing, let's talk a little bit about Slack. So in a nutshell, Slack's a communication tool. But like I said before, it's a lot more than that. And there's a little bit of lingo that goes along with Slack, but your basics are there are teams. Everybody who's on this Design Safe meeting or on this Design Safe webinar has already been invited to the Slack channel, the Slack team, DesignSafe-CI.slack.com. Design Safe or Slack has basically two interfaces. It's actually three. It's got a mobile application, it's got a web application, and it's got a computer app that you can load in as well. I highly recommend the application that you run on your machine and the mobile app because you get push notifications. So anytime conversation involves your name or a topic of interest to you, it will go ahead and give you a notification. So I already have Slack loaded on here. So let me go ahead and pull that up real quick. So here is Slack. Here's a list of basically the information that you have, your account, your preferences, and whatnot. We'll talk about that in a bit. You see a list of all the channels. These aren't all the channels. These are just the ones that I have decided to subscribe to. So think about a challenge. Think about a channel as a topic. So if you have a general topic that you want to talk about, or even a very tight topic that you want to talk about, feel free to create a channel to discuss that. We have some general ones already. Let me go ahead and open those up. I'm going to create one. Let's go and browse what channels we have on Slack right now. So these are the channels. You have the coastal engineering, geotech, structural, multi-hazards, open seas, the portal. So Design Safe is working on a portal, so you can come here and you can see what the status of things are. All of the entire Design Safe team here at TAC and all the PIs and co-PIs are on this. So you can talk with them directly. We have a channel for Jupyter, so if you have any questions regarding Jupyter, feel free to jump on the Jupyter channel and talk about it. And then, of course, we also have training. I'm going to create a new channel, and this channel is going to be for today's webinar. So I'm going to go ahead and call this, let's see, what is today? Today is the 1st. So do Jupyter Unleashed. How to place. So we'll just give a webinar and give it today's date, which is 03/01 and 2017. Discussion. Python Unleashed for Design Safe. And give it today's date, 03/01 and 2017. And then you just go ahead and send invitations to other people that you would like to have on this channel. For example, Steve Mock is here inside the room, and I'm going to go ahead and invite him if I find him. Also, Tim Cockrell is one of our PIs on this. I will invite him as well. And that's good for now. You guys are all welcome to join this channel. After this webinar is over, we'll take the conversation because we'll close out the Zoom session, so the chat will disappear. But we'll take the conversation to Slack, and then we can talk about it more there. So I've created this channel, and it is, where'd it go? Created. I hit cancel instead? I probably did. All right, webinar 03/01 2017. Discussion questions for webinar posted on March 1st, 2017. Steve and Tim Cockrell and create channel. All right, channel's been created. It gives you some information regarding this channel that you have. And I'm going to go and click there. Now, what's kind of slick about this is any conversations that are here will be displayed. So, you know, Steve just said hi to me. I can also, you know, replay a bit, hey back. And as soon as I start typing a name, it will recognize that name, and I can actually tag that person. And it'll come up as a notification on his machine. Brian Beck has also joined as Joe Stubbs, one of our chief developers for the Agave project. And what's also really nice about this is we can share documents. So what I can do right now is I can pull up my Finder. These are today's slides. I can go ahead and take this slide and upload it to Slack. And so anybody now can download those slides if they'd like to. We can also, of course, link to the YouTube video. We can also pin conversations. So if I'd like to, I can pin this so everybody be able to see it. And of course, we can invite other people, and we can also do one more little thing. So, you know, here's where we have any pinned items. I'm going to go ahead and pin this to the webinar. Yes, pin this file. So now this file's been pinned, so people can now download this as well. The other cool thing, of course, so that's channels. We also have something called threads. So threads are essentially created if you want to be able to have a sub-conversation within a channel to not clutter up the channel. So I can start a thread here with Steve Mock. And now, hey Steve, this is a thread. So if you notice, the conversation now is tied into one reply. Therefore, it's not clogging up the main channel. Steve and I can still have our conversation on the side, whatever our topic of discussion is. And if we come across something that is relevant to the rest of the channel, I can go ahead and say, hey, let's share this. This is a relevant conversation. I can now also send it to the channel itself. So now it comes up over here as our discussion that this is a relevant conversation. So the rest of the people on the channel can therefore see what was discussed or what was decided. So that's one of the aspects that you can do. Of course, there's a lot more things that you can go in as well. You can do searches. So I can do a search on people. I can do a search on conversations. I can do a search for keywords. And speaking of keywords, one of the other settings you can do is go to notification preferences. So we can have notifications on this channel. So any kind of activity that's going to happen on the webinar channel, I'll get a notification on. If I prefer just mentions of my name, I can just click mentions my name or highlight words, and then I can go ahead and give a list of what words I want to get notified on. So if I see the word training coming up anywhere on the DesignSafe team, it can automatically ping me. If I have a highlighted word of Jupyter, it'll go ahead and ping me. And the same thing with mobile push notifications. So anytime any conversation comes up, it'll push it to my to my mobile device as well. And if you go to your account preferences, your main account preferences, you can go ahead and get your main notifications there. All right. Go back to DesignSafe here. And done. Actually, I should change that. Activity of any kind. And of course, we can do that on a group level as well. So we can also see what, I can look at my account, edit my profile, and change my settings. It's going to take me back to the site, which I don't want to do right now. And get the rest of highlighted words, rest of names, conversations, and be able to view those. You also have just a link up here, which is just all your threads that you're involved in. So that makes sure that you are in the conversation at all times, and you don't miss anything that's happening on any of the sub-conversations. So what this really does, it gives a nice way for a team to communicate. It is a great way of cutting out some clutter and it's a very nice way of being able to search for data. So, like I said, after the presentation, we are going to be closing out the DesignSafe, the Zoom session, and that chat window will automatically close, but we'll take this conversation over to that Slack channel. So if you have further questions on using any of the technology we talk about, using Jupyter Notebook, Python, using Matplotlib or Pandas, we will be able to answer any questions there at that time. All right, so I hope to see you guys on Slack afterwards. All right, so the next thing I want to talk about, one of the biggest, basically one of the most useful items on DesignSafe for creating custom applications are Jupyter Notebooks, all right? If you tuned into our previous webinar, you'll know that there's a lot of applications on DesignSafe, the Data Depot, the Discovery Workspace, and that gives you a plethora of scripts and programs that you can run with our cluster on the back end. One of the things that we offer, one of the applications is Jupyter, a Jupyter Notebook. So in a nutshell, Jupyter Notebook is an interactive computing tool that is designed to capture the whole computation process. So you do your development, you do your documentation, you execute your code, you take your runs, you save your data, and be able to communicate your results and share your notebooks with other people. So essentially, how do they work? So a notebook has so the way the notebooks work here at TAC, we use something, or on DesignSafe, we have this thing called a Jupyter Hub. So essentially what that does, it acts as a proxy. So we have a cluster, and that cluster essentially has an image of Jupyter on there. When you go in there and you start your server, it essentially launches that Docker image and opens and creates this notebook for you, or your notebook environment for you to run. So it means that when it's running, it's actually running on a separate machine, and that separate machine is basically your own environment. It is not a shared location. So anything you do there is only on your data, on your My Data network. So, excuse me. All right, so what we're gonna do now is I'm gonna go ahead and jump in to Jupyter, and then we'll talk a little bit about what we're seeing. So to get to Jupyter, you can go through DesignSafe, the research workbench to the workspace. I should mention, by the way, so these webinars that we have here are kind of hands-on, so feel free to follow along with what we're doing here and seeing if everything works for you. If you have any problems, go to the chat window and raise ask a question, and one of the tech guys will be able to help you out. All right, so here is the Jupyter application. I'm going to go and click that, and go ahead and click Launch. Normally, since I already have my Jupyter running, you will have a big button. Actually, if I go to my control panel, you should be able to see that. You'll see something like this. It'll just be a launch your server. After you're done, if you want to stop your server, you can. Like I said, what happens is this spawns off this image that is now running on a cluster, and that is essentially your environment to run in. Now, it should be noted, any modifications you make to that environment, when you go ahead and click stop your server, so you're logging out and closing everything off, those modifications will be gone. So any custom apps or custom modules for Python that you install on there will be gone when you stop your server, and then you have to essentially relaunch. All right, I'm going to go and click onto my server, and I'm going to click on My Data. So if you remember from your experience with DesignSafe, how DesignSafe is set up, the Data Depot, everything essentially goes into your My Data location. So here is My Data. All my files are sitting inside here. So those are the exact same files which are accessible through Jupyter by going to My Data. All right, so here's My Data, and then here's my folders, and here's all my applications, notebooks, and things I have in there, which really, honestly, I should really clean up and make this a little easier to access and a little bit better to get to. All right, so I'm going to go ahead and open up just one of my notebooks in particular, all right? So the way these notebooks are set up, they have two parts to them. Well, really three, but two major parts to them. One of them is a code cell. So down here, this is where your code sits. And then the other one is what is called a Markdown cell. So the Markdown cell is essentially where your notebook, where your documentation sits. The way I kind of like to think of these notebooks as being is essentially exactly how a laboratory notebook would work if you're doing an experiment. So when you're doing an experiment, my dad used to work in a wind tunnel, so I always use this example. He used to keep a journal of all the experiments that he's running, what the settings on the wind tunnel were, what the which tool was currently holding on to the model, velocity, all these other parameters, and they're all jotted down in a notebook. And then, of course, the results afterwards were printed out, and those were kept in the notebook as well. So essentially, he could then give that notebook to somebody else, and that somebody else could replicate his entire experiment from beginning to end and validate his results. So a Jupyter Notebook would essentially be the same thing, except now we're doing the exact same thing, but for your code. So you can put your program in there, run your data against it, load your data, do your analysis, do your visualization, and get your results. And then you'll be able to take that notebook, hand it to somebody else, and they'd be able to essentially validate your work by going through the exact same code. It's a really good documentation process. So exactly like a laboratory notebook would be. So anyways, you have your Markdown cells, which is essentially where you put documentation, and you have your code cell, which is what this is right here. And you can have as many code cells and as many Markdown cells as you'd like in your code. Also, this only has one code cell. Your code cells can run in different orders. So you can run one cell before another cell and so on and so forth. So if you're having one part of your program works great, one part of your program is still kind of buggy, still need to clean up, you can just make your modifications to that cell, rerun it until you get your bugs fixed. All right, so moving on. So your Markdown cells are kind of cool. So essentially you can add headings. So if you do like a hashtag, so if I were to go inside here, this is what it's set up as. If I can then write down, oops. If I were to make this into a heading instead, I can just put a hashtag in front of that and then say, hey, I'm going to solve AX plus B. Shift enter to go ahead and modify that. And now that's a heading. Subheadings, you can then go ahead and put in multiple headings, double hashtags for a subheading, and so on and so forth. You can also make lists. So you can make an ordered item and or unordered item, and basically just make your notebook look as intricate as you need to. Since these are Markdown cells, HTML is a markup language, so essentially it takes pure HTML in there as well. So you can essentially just put in some HTML markups, put in whatever you want to say, and it'll go ahead and render the HTML for you. And it even does latex. So if I wanted to, I can take that little bit of latex, PDF copy and paste hardly works for it. So Command C. Copy. And if I just want to do this, and put in that latex in there, end it with a $sign, and it didn't render it. Great at that. Wonder I have that, I think, formatted wrong. So I need to look at part of that. Yeah, there it goes. So now I linked it. Space was wrong. So it's a $sign, space, and then your equation, and it will render the latex for you. Which is very nice because especially if you teach any classes and you want your students to make the equations look pretty, you can give them a Jupyter Notebook to do their code in, and also be able to put their documentations and also put their equations in there and make their equations look pretty. Of course, I don't need that equation in here, so I'm going to go ahead and delete that out. All right, so this is just a simple, this particular notebook is just using the Jacobi method in Python to solve AX equals B in an iterative fashion. And as soon as you're ready to run, you hit Shift Enter, and it runs your program for you. And then you have this output cell. So here's your input cell, and then you have your output cell that you can see all your output in. So your workflow, like I said, that kind of varies from person to person. Essentially, you will work on your computational process in pieces. So if I wanted to, since I already had this, I just copy and pasted it in there. I could split this up. I could have this function. If I were to say insert cell above, I could take all of this and put that into a different cell. So now I have my, my imports of my modules and my Jacobi function defined in one cell. And then I have actually using the Jacobi function in another cell, so I'm splitting up my code. And of course, the problem is if I just run this cell down here, it's gonna actually, I think all cells. Since I'm actually defining the equation up here, it's gonna want to look for that. So cells kind of have to be ran in the order you need them, but you can run them in any order after you do all your declarations. All right, so we already talked about that, how your workflow is set up, and then you have little shortcuts. So Shift Enter automatically runs a cell. So if I'm in here, Shift Enter will automatically run that and take me to the next cell. And I can run that cell after that. Control Enter runs a cell in place, so it keeps your cursor in the active cell, doesn't move it to the next one. And Alt Enter, run the cell and insert a new one. So that's always handy if you're running code and writing code at the same time. That way you don't have to keep entering or creating a new one or creating a new cell. All right, so that's really Python in a quick, or basically Jupyter Notebooks in a nutshell. All right. I'm assuming most of you guys already know Python, so I'm not going to dig into Python too much. What I do want to talk about is Numpy. I know a lot of people use that. I know some people don't quite take advantage of all the cool data structures that Numpy can provide. So I want to kind of emphasize in this webinar how cool Numpy is and what it really is good for. And I'll give you guys a couple little quick examples, real-world examples of how Numpy is a little bit more efficient, and some of the data structures in Numpy are more efficient than the core data structures that Python gives you. All right, so Numpy stands for Numerical Python. It's an open source extension, which means that anybody can get it, anybody can add that in, import it in, just have to do a pip install. Numpy is already a default package on Jupyter on DesignSafe. So you don't actually have to install that yourself. And essentially it just kind of adds you some really quick, efficient ways of doing things. All right. So first steps. This is if nobody's ever done that before. So what I'm going to do is I'm going to go into, back to my notebook. I'm going to go to My Data. I'm going to go ahead and click New. So these are everything that's available for you. So we can do a text file folder. There's also a terminal session. We will talk about that here briefly in a little bit. And then you have different kernels for your notebooks. You have Bash, Python 2, Python 3, and R are the default ones that we've given you access to. So I'm going to go ahead and fire up a Python 2 notebook. And the first thing we're going to do is we're going to go ahead and import Numpy. And I'm going to call that as NP. And I'm going to hit Shift Enter. So it's going to run that. It does the import. And then just do a really simple list. So I'm just creating, this is just a standard Python list I'm creating right now. And we'll just put some numbers in there. 0.5. All right. And okay, so I'm just going to go ahead and run that. So if I just do C values, it's going to go ahead and print out that list for me. Now, I'm going to go ahead and convert that list into a NumPy array. And just hitting enter by itself without hitting shift enter just gives me a carriage return. And I'm going to go ahead and print out C. So now, really quick, we've created a list of numbers. And now we converted that numbers into an array. So notice, first thing, it tells me it's just a regular list. Now, it tells me that this is an array. So that gives you a little bit more flexibility on what we can now do because we're now using an array. For example, we can multiply our array back out. So I can say, C times, actually maybe C times, just a number straight through. Run that, multiply everything by 9. Versus the old method of doing things with a list is having an inline for statement that goes through all the values in our list and then does whatever you want to do with them. So it gives you a little bit of NumPy gives you a little bit more handiness and clears a lot of stuff up for you. So it's not quite, so your code is not quite so cluttered. And of course, there's some cooler things we can do with NumPy as well. This is a little sample code that I found that essentially does a little bit of timing. So I'm going to go ahead and copy this. And I'm going to go ahead and paste that in. And we're going to go ahead and run this. So this is a traditional pure Python version of looping through and mixing some data in. All right. This is the NumPy version. So a couple differences. You see the way that I'm using range versus the NumPy arrange. Shoot. All right. And my carriage returns right. And that as well. All right. So here you notice I'm setting up X is going to be 1,000 items. Y is also going to be 1,000 items. I'm creating this Z that's going to be empty. I'm filling Z with X plus Y, and I'm doing that for length of X, so all 1,000 items. Here is the NumPy version, which is just setting up, once again, just some items, time times time. I'm arranging those into X, arranging those into Y, and I'm just saying Z is equal to X plus Y. All right, and then I'm going to, let's go to the next slide here. So we can see which one is essentially going to be faster to run. And so I'm going to just go ahead and type this in. T1 equal to my pure Python version. And T2 is going to be equal to my NumPy version. And these should both return at time. And let's just go ahead and print out T1 and print out T2. And I didn't get my T2 printed out. So if you notice, actually it did work out this time. I'm going to go ahead and take this code out and put that in with my T2 down here to make life a little easier. T2 equals, sometimes just easier to type, NumPy version, and print out T2. All right, so run T1, took 0.0007 seconds, run T2. It took 0.0001 seconds. It also, a couple of these, like this one, this run, for example, 0.0008 seconds. So it is about 10 times faster, 10 to 100 times faster, depending on how your system is set up. So essentially what we're saying here is, if we use NumPy properly, and if we set up our code correctly, we can gain a lot of performance using NumPy versus using traditional Python. And like I said, this is just a simple item, 1,000 copies, and we're seeing a serious factor of performance. So I'm not going to dig too much into NumPy, because NumPy gives you a lot of cool stuff. It can give you, obviously, gives you access to arrays that we always use instead of lists like we did. It's like we did here. But the big thing that NumPy gives you is multi-dimensional arrays, and it gives them to you in a very nice, easy to use fashion. So here we have I'm going to go ahead and use that. So I'm going to create a NumPy array, and I'm going to go ahead and fill this up. So we're looking at a 2-dimensional array, and it's pre-populated, and we're just going to go ahead and print out what A is. So I'm actually going to just print A, run that. Oops. Oh, don't need to, please. All right, so print out array A, and then let's get some information about it. Let's just say A dot. Now it's kind of nice, by the way. So unfortunately, autocorrect has kind of made us into lazy programmers, but when we're talking about object-oriented programming, you have no choice but to be a lazy programmer, because there's so many parameters and so many public methods available to you that it's just hard to remember them all. Jupyter is very nice. If you just hit your object A and you give it a dot and just hit tab, it'll go ahead and autocomplete for you. So you just find what it is we're looking for. I'm looking for ndim, just tell us what the number is. And as you start typing, it'll narrow down your results. So select what it is you want. Hit enter, and it tells us, it's a dimension of 2. All right, which is what it is. It's a 2x2 matrix. And same thing, we can also create here another one. I created B. I might be using B here in a little bit, so I'm going to go ahead and pull that in. So we're going to fill up B here as well, another array. And just because the PDF is changing out my values. One more stream on that. And make sure everything is lined up properly. All right, looks good. Let's go and run that. So, all right, it tells us there's 3. All right, very good. Things are working. And of course, there's other cool things you can do. You can also, you get the different values in there. We can also do shape. So shape is another one that's kind of neat. So I'm going to go ahead and pull out X. And copy that. And put that in my notebook. And then we'll go ahead and hit enter there. And I'm going to go ahead and say np.shape X. And it's telling me it's a 6x3. Now, shape is really cool. So basically what I'm doing is I'm giving you what my favorite functions are in NumPy that I've actually used quite a bit. Shape is kind of neat because we can then change the shape of stuff. So if I wanted to, I can say x.shape equals, make it a 3x6 instead. And let's go ahead and print out X. And now it's changed it from, actually, maybe I should do this one again and print out X. So there is X right here. By changing its shape from a 6x3 to a 3x6, now we have a new array. We can even, as long as things line up properly, if we can still do the math, we can change it. So we can make it into a 2x9 or 9x2. It's 18 values in there. Oops. And it'll take that, and I can print out X again. So now it's a 2x9. I can change it one more time and make it 9x2. Oops, if I spelled it correctly, it would probably be nicer. Oh, that's right. Oh, that's because I didn't do it equal to. And print out X. All right, now of course, if you attempt to shape it into something that is not compatible properly, so let's say if I say 4x4, because that's only 16, it'll throw us an error saying, hey, it can't do that because the number of characters or the number of elements do not match what's inside there. So it will give you errors. You can't just arbitrarily change the shape of your matrix. Other things you can do, of course, is a couple more examples of shape here. If you want to see that, you can do things like you can do a scalar. So I can do np.array and only give it a number. And if I do np.shape of x, it'll give me, hey, it's only it's not a multi-dimension. It's only one number in there, so it comes back. Versus we already have b inside there, so I can say this is the other thing also. Since I'm not sure how many of you are familiar with Jupyter Notebooks or have used them, but because I have b up there already, if I did this, it'll just give me back the b value that I had. So I can do a shape np shape b, and it'll go and tell me what shape b was. All right, the other cool thing about, so now that we have a matrix built and we can figure out what the shape of stuff is, we need to know how are things indexed, all right? That should be kind of simple for you. One of the really cool, I'm just gonna go and load, I don't remember if I'm using F in any more examples, so I might wanna go ahead and put F inside there as my array. Just so I know it. All right. So there's my array F. 0 will always give you the first element. So if I just do F of 0, F0. Oh, what did you make? Oh, because I did F0. And Python is case sensitive. So it'll give me the first value in there. And what's cool is -1 will give you the last value. Same thing with multidimensional razor as well. Since b is still in there, I can say b sub 0. And then of course we can go ahead and say, all right, give me the second element and go in depth. And it'll give us what the number was in there. All right. Also, of course, we can do slicing. Slicing is pretty important too. I'm sure some of you who are Fortran coders have seen this format before. I'm gonna go ahead and paste that in there. So I create an array here. I lost 4 or 5. And 51, 52, 53, 54, and 55. And close bracket and close parentheses. All right. So I can create this, and we can look at A. Do a.shape. Tell me what the shape of A is. And of course, we can do cool things like, hey, what is everything on 3. And, and it'll give me that chunk of array out. So we can slice our data out as we need to. And of course, you know, we can go a little bit deeper in our slice. We can say A colon 3 and 2. So everything in this box. So I'm saying, all right, give me everything from 3 on up to 2 deep. So then there, and so it'll just give me the, for that little chunk there. So slicing is also really, really, really handy to do, especially when you have big data sets and you're trying to narrow down your fields. All right. And of course, the lovely things that it does for you, it automatically creates identities for you. So I can create an identity matrix with just the term identity, I can spell, and then tells me how many I need. And it automatically creates an identity matrix, which is very useful as well. And then, of course, I want to show you guys this little example here. And I'm going to go ahead and make this, maximize this. I want to make sure we have time for everything, so I won't actually run the example on this. But so this is just a really trivial little case. It's a 2D Laplace equation. It's using a 4-point averaging. Anyways, this is what the time step would look like under if we're just to go ahead and program this without using any NumPy, right? And you know, we'd use essentially a for loop, nested for loop, set up our UIJ, and so on and so forth, and go ahead and loop through that for our number of X and our number of Y, right? Which is actually not too bad. It's actually pretty quick. But when you go to a big data set, say even relatively small data set, like 500 by 500, this is going to take quite a while to run. Versus going into this version, which is using NumPy expressions to run it. So same kind of deal. We're still running it, but now this is where our iteration is. Instead of going through that entire nest, we're just doing slices and stepping through each different value. This version runs about 100 times faster last time I timed it. And so therefore, learning these little tricks where you can slice your data up, where you can maneuver through your data all in one line, you'll actually gain a lot of improvements. And that's one of the things we're trying to do, is make sure you guys run code that's efficient. All right, so we're going to move on. Of course, once again, after the webinar is over, feel free to hit us on Slack if you have any other questions on NumPy, and we can give you some more examples or point you in the proper direction. All right, so there is a kind of a method to what our madness is today. All right, we're trying to show you, all right, here's ways of computing your data. Here's ways of slicing your data and modifying your data. And then, of course, we need to give you some other methods of manipulating it and viewing it and saving it and, of course, recalling it. And that's where Pandas come into play at. Excuse me. All right. So Pandas has an acronym. It stands for like panel data or data panel or something, which is just panel data, I think is what it stands for. And it's essentially telling you, hey, you can do some really cool data structures with it. And which you actually can. Once again, Pandas are also available by default on Jupyter Notebooks. All right, first steps. We showed you NumPy. You import that in. We have to import in Pandas. I'm going to go ahead and do that down here. I could also just do it up here as well, which I might as well. And just rerun that import. Pandas as P. Rerun that. And go back to the bottom of my notebook. All right. So Pandas allow you to create really cool little data sets. It gives you some more abilities as well. It gives you almost SQL-like abilities, which is really kind of slick, especially I used to be a SQL coder. So one of the first things we want to do maybe is we can create a really quick series. And if you notice that we can, a lot of these things that we're doing, we can also do in, and of course, autocomplete works, series. And I'm going to go ahead and say, all right, let's go from 1 to 3, 5, np.nan, which we'll go back to here in a bit. And 6,8. We'll just go with what my example has. Oops. Go. That's because they're not supposed to be brackets. That's squigglies. So my one complaint of Jupyter is I am somewhat colorblind. So when you do your auto, when it tries to be helpful to you and show you what your brackets are, it turns yellow. And that essentially disappears for me because it kind of looks like the gray background. So, oh well. Anyways, run that, print out my series S, and see what we have. And it gives me my series. It also tells me my type, and it gives me the NaN. So essentially, NP-NaN stands for not a number, and so it gives me a not a number. That comes into really useful play when you are importing in a data set or computing a data set with missing data. So essentially what you want to do is take that missing data and insert NaNs inside there, and then you'll be able to run a query and pull all those not a numbers out, and therefore you have a full data set. We can also do really cool ranges. So if I want to do, I can do a date range, excuse me. I can do dates, and I can do panda dot, I'm just going to do autocomplete, and date range. Now we can feed it a date, so I can go, all right, 201, what is 17? 301, and then I can say, all right, divide that, single quotes Charlie. Divide that into how many periods? So I can say, hey, divide that into, we'll go with the example 6. I could run that and then view what the dates we got. And so it now gives me gives me a period of 6 dates. So go from 0301, 0306. And I can increase that, decrease that, however I need to. And of course, we can do lots of cool things with random numbers as well. We can actually still play with our data frame. So we can create a Panda data frame in this case. With random numbers equal to the dates that I've already pulled out. So I'm going to say, all right, I need a data frame. I'm going to create it with random numbers. And that random number comes from Numpy. Numpy is a really cool random number generator. Of course, it's not truly random. What size of random numbers do I need? I can then say, all right, I want to index that on my dates, and I want to give it column names. Remember, what Panda is really for is to allow you to create data sets. So I can go ahead and create that. And let's look at what we got. So that creates a table for me. Here are my dates. And then here are my columns, A through D. And then here are the random numbers I use to fill out the data sets for you. So now if I wanted to, we can then start querying this data. We can start joining it with other lists and so on. And then we can go a little bit further. So I'm going to go ahead and create this second data set as well, another data frame. And let's see what DF2 looks like. So now, got a little bit more advanced. We're we're giving what individual we're creating columns and rows. We're saying we're going to fill it out with a timestamp. So we got a timestamp in there. A is going to be filled with ones. B is going to be filled with a timestamp that's coming from Panda as well. C is going to be filled, so here's C. C is going to be filled with a series, and the series is a Panda series from 1 to whatever index I want. I'm giving it a range of 4. D is going to be filled with, and the C is of course going to be type float. D is my next column. It's going to be filled with an array of 32s, so it's all the way across. And then E is going to be categorical, so it's just going test, train, you know. So I have it filled with. And then F is just going to say foo all the way down. And so you can build these little tables up. So of course, in your cases, you guys are going to be running programs, going to be running code that's going to be generating data. You're going to want to create that data and put that in some sort of a table format because it makes life easier to work with, easier to use. And then you can go ahead and pull your data in, create your data frame around it, and then be able to save your data out, which I believe, look at the text. Oh, yeah, well, these are some of the most common useful functions that you can do with data frames. You can look at a little sets of them. Excuse me. Did I do that? All right. So I can do df head. Oops. It'll show me the first few columns. I can specify a number, so I can say 3. It'll only give me the first 3 columns. Same thing with tail. Do df.tail. And it'll give me bottom up. And I can say, all right, just give me the last 3. You can do cool things like df.index. So we're going to want to know information about it. They'll tell me, hey, it's indexed on the date time, because that's what I set up at the top. I said, hey, index it on my date time. So it goes and tells me that. We can transpose our data. So df.t. Now data has been transposed, so rows and columns have been switched. And of course, we can now also sort stuff as well. So you can do a sort on an index. You can do sort on a particular value and continue playing over there. And you can then we're going to go into there's selecting data, and then there's a quick summary of features. It's now 2 o'clock, so we've been for about an hour. Let's take a quick 5-minute break, and then we'll reconvene, and we'll go on to talking about Matplotlib. And actually, we'll finish Pandas up. We'll talk about CSV files. Those are going to be really important. How do you save files out? Where do the files go? How can you access the files again later? So we'll talk about that. And then we'll move into some Matplotlib and some animation and see if we get some interactive plots going. All right, so let's take a 5-minute break, and we'll reconvene about 2:05. All right, thanks, guys. All right, guys. Hope that break was enough for y'all. I'm just going through some of the questions and seeing what people are answering and asking. Very cool. I think I have come across a C++ library or kernel on Jupyter, but I don't think I've played with it yet. So I do remember seeing that somewhere because one of the classes we teach here, we're thinking about using Jupyter as the main IDE for students to use, but I have no experience with it. All right. Okay, guys. So let's go ahead and finish up Pandas, talking about it. I know you really want to be able to save your data, and Pandas really is the best method of doing that because not only can you save your data, but you can also analyze it. Like I said, I would suggest going online and reading up on a little bit more about Pandas because it does a lot more than what we're talking about. For today, I could do a 2-hour webinar on Pandas, and we're just trying to get a lot of features going here. But anyways, Pandas you can do Boolean indexing, which is really cool because you just essentially, hey, if something is greater than something, go ahead and select that row for me. You can do a bunch of statistical ops, histogramming. You can merge data, so you can take 2 data frames together, say which columns you want to merge the data on, and it will merge that. So those of you who come from a SQL background, you can do SQL style joins, which is really slick. And you can append data to an existing data frame, essentially almost just like a SQL style. And then you can also do groupings. So when you're reporting your data back, you can do groupings on that. Just like we did with Numpy, you can reshape your data as well. And you can create pivot tables. So you can create multiple pieces of data all hooked up to a single row that you can then pivot your joins around. And there's a lot more things you can do. Unfortunately, with Jupyter, you can't do that, but Pandas also support plotting. So if you're running Jupyter Notebook locally, you can then use an interface to be able to plot your data. It takes a little bit more, a little bit of finessing to do with and tweaking to get Pandas to actually graph in Jupyter on DesignSafe for Jupyter Hub. But honestly, if you're going to do graphing and stuff like that, I would suggest using Matplotlib anyways. But the one thing that we want to talk about really, because that's what makes Pandas nice, is be able to create CSV files. All right, so we're going to create a quick random number using a random number generator, create about 1,000 random numbers and be able to create a table out of it, and then be able to put that table into a CSV file, and then obviously call that table back. And there's a couple things, there's a reason I'm bringing this up, or I'm actually doing a demo on this, because I want you guys to see where the file actually goes, all right? So I'm gonna go ahead and do a time series, pd.series, and NumPy, and I've used random numbers. I need 1,000 of them. We're going to create an index. The index is going to be a date range. Date range. It doesn't matter. I'm just going to go use my default that I put in the example. And we're going to say we're going to start from January 1st, 2000, and we're going to go ahead and need 1,000, so periods equals to 1,000, which is really, by the way, slick. I didn't mention that before, but if you do like we did, thousands, you can go, or hundreds of thousands, it will actually go ahead and do your proper dates for you, which is kind of slick, which makes life nice. And yes. Yes, we're going to go ahead and do a cumulative summary on that. let's do make sure we got information inside there. And we do. All right. So I just had to print out the top 5. We can also, of course, which is nice because there's 1,000 in there. So I really don't want to print out all 1,000. So I can just do a tail, see what the bottom 5 look like. That's really good. Everything looks good with our random numbers and with our dates. All right. Next thing I want to do is put that around, put a data frame around that, and then put a little, do some index columns so things look a little bit more like what a proper table would be. So we're going to create a data frame, use a Panda data frame here. And once again, I need my random numbers. And n. And set to 4. Set my index is going to equal to my series I just built a little bit ago. So index ts.index. And then my columns are going to be A, B, oops. C, O, C, and D. Close bracket, and close parenthesis. Type something wrong again. Oh, EOF all parse. So I must have missed a bracket somewhere. Index columns equal. I hope it's columns equal. And done this right there. Yeah, that's very good. All right, very good. Go do a df equals df.c1. Let's do a cumulative summary on that. And let's do df.head, make sure I got information in there. Very good. df.tail. All right, things look good. So now we have columns of data. We essentially took that information we had, split it out, and so now we got some good columns in there. All right, so things look normal. Now what I want to do is now we're going to write this thing out to a CSV file. It's a comma separated file. Then if we wanted to, we could download and open up into Excel, or one of our other viewers, even Google Sheets does CSV. So I'm going to go ahead and say df.toCSV. Actually, toCSV. And I wanted to do it this way so you can see other formats. You can do it to your clipboard. So then you can cut and paste that somewhere else. You can do it to an Excel file. You can do it to a JSON file. Go straight to LaTeX. So there you have other options besides CSV. CSV is just probably the most easiest to deal with, especially for tabular data. So CSV, and I'm going to put that in. I'm just going to put in food. I should give it a real name if I wanted to. All right. So now that wrote the data out. So now let's see where the data went to. So technically, we have our my data information here. And I want to make sure, I want to see if foo went there or not. So there is the file I just created, foo.csv. If I go and open it up, you see there's my comma delimited file. Also, because this is all within DesignSafe, if I go to my data depot and do a refresh here, we should see that foo file in here. Might take there it is, foo.csv. And of course, I can then pull it in here, and it should give me a file preview since it's a CSV file. But it's 1,000 by 1,000, so it might take a little bit. And there is our preview file in CSV in DesignSafe. So if I wanted to, now I can take this file, I can share it with other people. I can now copy it, move it to another directory, rename it, and whatnot. And it's interesting is because that file was created through our Jupyter Notebook, and which I'm going to go back to now. All right, so that's how you write it out. This is how you read it in. You have pd dot read CSV. File you want to read. And you read it in, and it goes in and pulls all your information in. It's 1,000 rows, 5 columns. So now, using Python and Numpy, we can essentially create large amounts of data. We can create rather efficiently if we do our Numpy slicing properly. Then we can pull that data into a Panda data frame. We can take that Panda data frame, we save that out to a CSV file. With a little bit more advanced Panda techniques, we can go ahead and do more information on that. We can join it with other data sets. We can do our statistical operations on it, and so on and so forth. All right. So that brings us up to Matplotlib. Okay, we're not going to spend too much time going into the nitty-gritties of Matplotlib. We might do a couple of the first few demos just so you guys get a good feel of it, especially for those of you who've never used it before. Matplotlib is essentially designed after what some of the graphing techniques you can do with MATLAB. So essentially, Python gives you the scripting abilities. Matplotlib gives you the graphing and the plotting abilities. All right. So first few steps. One thing that we do, there is a couple different ways we do this. These are essentially magic keywords. I don't really like using that word because I don't like things being magical. Essentially what we're doing is we're saying, hey, all of our plots are going to be inline. So essentially they're going to be coded in the bottom of, coded in the window that we're programming in. The problem you're going to see, you're going to realize this pretty quick, is that they are not interactive plots. All right, I'm going to go ahead and put that at the very beginning with everything else, just so I know I don't lose it. Make sure I got it names right. All right, so we're going to import in matplotlib.pyplot as PLT. Oops. That's rather interesting. All right, bear with me here a sec, guys. I want to see my Matplotlib demo, which worked. So we've come across this problem before in Jupyter, where certain libraries, there's some sort of race condition going on where certain libraries are being loaded before other libraries are being loaded. So if you see that problem come up, like we just see with the Matplotlib pyplot as PLT, essentially there's a race condition going on. You may need to run that line a couple times to make sure that it gets ran. It's a very interesting error, though. All right. Essentially, I'm going to go ahead and do this, and I'm going to go and clear my cells. So I'm going to go ahead and clear outputs. I already have this notebook set up. All right, so the first few things we have to do is we declare matplotlib. We say it's going to be inline. All right, so essentially what we're saying is all these plots are going to be non-interactive, and the data is going to be there, and we're going to run it. All right, we import in our libraries, and that runs just fine here. Didn't like it there. And then we have our NumPy come through. All right. First thing we're going to do is we're going to say, all right, you know what? We're going to decide that we're going to plot a simple sine curve. All right, so let's go with a simple sine wave going from 0 to 2 pi. Sine waves are easy, especially when we're later on this notebook. We're going to start animating this, and that's going to get a little bit tricky. So a sine wave is very easy to plot, very easy to animate. Okay, so first thing we're going to need to do is we're going to need to use our NumPy, and we're going to equally essentially create a space going from 0 to 2 pi, and we need 50 points of it. All right. So PLT, that's what our numplot is. We're going to say PLT.plot, and what it is we're going to plot. We're going to plot x, which is what we just got, and we're going to plot sine of x. And we're doing plot.show. So we get our simple sine curve. We have 50 values going from 0 to 2 pi. And that's kind of interesting to see, but we know we can then change it up a little bit. So we can do what we have plt.plot, and we're going to change the way our lines represent, or actually what we're going to do is we're going to introduce a secondary plot on here. So we have now x. First plot is going to be np.sine of x, and our second plot is going to be x and np sine 2 of x. And then we'll show that. So now we have our two sine curves on one plot. We can change things around a little bit more. So here what we're doing is we're adding in different dots to be able to graph it. So instead of using our standard just points, we're now saying, all right, let's do one of them with O's, and we'll either do the other one with dashes. We're also going to say make one of them red and make one of them green. I just do that to keep myself on the toes because I really can't see the difference between those two colors. All right. The other thing we can do is we can add subplots. So by the way, these are the other colors that it supports. Blue, green, red, cyan, magenta, yellow, black. Black is K, by the way. I just made a note because B is being used by blue. And then we also have white. I'm going to go back here, see if it's still doing that for me. It is. I wonder if I should shut my notebooks off and restart them. It's interesting. It's an odd one. Yeah, I think some people had that problem happen before trying to come up with Matplotlib. And like I said, it is a race condition that's going on, that library is being compiled before the other when the image is set, and so it's giving you that error. I'm sure we're going to figure out a fix on that. All right. Other things you can do is we have subplots as well. So you can create a main plot and then have minor plots inside there. So here we have two plots. One above the other, we're creating some subplots on there. And then we can do things like scatter plots. We can add some more color to it, make things a little random. That one's actually pretty slick, so I'm going to go ahead and run that one. So we're creating a scatter plot, put some random colors in there, and be able to create things out. Once again, realize this is not interactive at all, which is something we're working on trying to do. There's a couple of cool libraries I want to show you today that kind of give you a little bit more interactivity to your plots. And we can do things like histograms. We can do contour plotting. The contour plotting is actually rather interesting. So essentially what we can do is we can take a data file, we can take a CSV file, open it up. So we can use, this case I just use standard Python, but we can use actually Pandas, and that'd probably be better. We can build an array around it, and then we can add some color to it. I don't think I have it in here, but I do have another notebook that does some contour plotting that you can see how that looks. That notebook one's up. So I will admit you guys are kind of our guinea pigs on this. We were trying to see how much we can push our Jupyter servers to see how many of them we can handle. Since there's like 35 of you guys out there right now, I'm sure we have that many Jupyter instances running. Yeah. Somebody has a fix for the Matplotlib thing. Oh, thank you, Adam. That's actually a great idea. Let me make a note of that. Let's see if, interesting. Okay. If I declare the backend, that'll do it. All right. Appreciate it. Thank you. All right. So I'm going to go back to my other one and see if I put in the backend, if that'll do it then. Actually, we'll make it in line. We'll keep it in line. Matplotlib in line. Oops. Still getting Qt4 error. So I'm doing something way wrong. Yeah, we have to investigate that a little bit further, see what's exactly happening. That's like I said, I've had that error before. All right, see if I can open up that contour plot test and show that to you guys as well. But that notebook is not being responsive. Right. Anything being responsive? No, it's not. Kill my browser. All right, that's still going on. Hopefully it'll catch up with me here soon, and then I can be able to kill it. Because I'm not getting any resistance on there. All right, so you do other fun stuff with it. All right, one thing I want to show you guys. All right, there we go. So now my browser died. So let me launch that back up. And go back to Jupyter. And my data. And there's a couple of things I want to show you guys. All right. So there's, if anybody's ever done any animating before, or at least used Matplotlib to do your animation with, there is this cool function called func animation. It's under matplotlib.animation.funcanimation. And it's kind of interesting the way it works. So really what it does is it calls this func, whatever you put down in as func, it will call that as many times as needed to loop through. So we have matplotlib, animation, func animation, fig. Func is the function that's going to be calling over and over and over again. Frames is the number of frames that you want it to run. You can set up an initialize function if you like, where all your values, all your variables are initialized, and then you give it some different variables and arguments. So what we have is we have our Matplotlib and animation file. Did I just, yeah, I guess that's twice, I'm sorry. So this is an example of what we have. I'm gonna make this bigger and then I'll pull up the example we have and we can talk about it a little bit. So first thing I want to set up is set up our plot figure that we're going to do. So fig.equals plot.figure, all right? We're going to set up our axes, our X and our Y, and just so we plot out our lines, all right? And in this case, I did create an initial function, initialization function, that essentially is going to be whatever's plot the background of our frame. Now, this is the function that's going to be called sequentially. This is my animate. I'm going to be essentially go from, and once again, I'm doing the sign because it's simple and easy to do. I'm going to go from 0 to 2, and I'm taking 1,000 points. I'm going from 2 to pi, or I'm sorry, I'm doing a sign. Y is going to equal 2 times pi. And then I'm going to be moving through X. And I'm going to be drawing, essentially, I'm going to be returning this line that I just drew. That's essentially going to be setting the data XY. I'm going to return that line in this animate function. Animate function is taking in this value I. All right? Now, this is my animation start. So I'm doing my animate.func animation. I'm giving it the figure that I defined here. I'm telling it which function it's going to call repeatedly. That's the animate function. I'm telling it where it initializes at. So this is the initialize function. Telling it how many frames I want, what interval I want to be able to go through. And this is essentially all it does is says, hey, just redraw the parts that change. And then I'm going to call this thing called display animation, and I'm going to send this animation, func animation that's being created here to this display animation. Remember, this is going to be a little different because we're doing, especially for those of you who played with this before, we're doing this inside of a Jupyter Notebook. So we actually have to talk with essentially a movie writer and talk with what's going on. Talk with the movie writer that's sitting in front and then be able to render HTML essentially is what's going on. All right, so I need that display animation function, which is this. All it's going to do is it's going to take that animate, it's going to take that figure, I'm calling it animate here, and I'm going to return an HTML rendered anim to HTML. And so here I have this other function that I wrote. And this is really where it's not very pretty, all right? So there is a cleaner function out there. Unfortunately, it doesn't seem to want to work in our Jupyter Hub environment. So for those of you wanting to animate a time step function, for example, this is really the best way to do it. Next, I'm creating this HTML, so I need this HTML function as well. That happens here, all right? So here's my anim to HTML function call that I made here, this anim to HTML. So I'm basically creating a tag, just saying, all right, this is where everything's going to come from. This is why I'm saying it's kind of gross because this is essentially a hack and it's not very elegant. But what essentially I'm doing is I'm creating a video tag, all right, and I'm saying, hey, this is going to be a video of type MP4, and we're going to go ahead and visualize it. And then I'm putting all that stuff and encoding it inside of here. And then I am returning this encoded video, which is what I'm creating, taking all that information from that we built up, and I'm encoding it as a format. And when as in the video tag, in that I'm returning this video tag.format encoded video. So essentially what we're doing is we're creating a series of images. We are animating that. We're calling that animate function to be able to build those together for us. And we're creating an MP4 file is what we're doing. And then what we do is we just got to view that MP4 file. So we have this file here, animate test, that I created earlier. All right, so we're going to populate this thing. Here's my my anim to HTML function. Here is my display animation, and here's my my main library that calls it. And I'm going to go ahead and clear all my output. All right, and we're going to go ahead and run all of our cells. And it creates this file for us, which is essentially an MP4 movie. So if I hit play, it'll go ahead and play through that video. That sine curve that's being created by my animate function. And of course, it is an MP4 video, which means I can download it as a MP4 video, and then, or I can embed it in other places. So this is actually pretty slick to do. The other thing I want to show you guys is if you are creating a time step solution, and I'm going to pull that up here. I should have a heat equation. Unfortunately, I don't have that in my slides. I created that for just a little bit ago. And where did it go? My archives. Oh, this 1D heat equation. So it's just solving a very simple heat equation. I have basically a bunch of sine curves through time. This thing is going to narrow. Because the movies are nice, but sometimes you actually need to have the independent slices that you want to be able to pull out. So you can do it this way. I'm going to go ahead and clear the output here. Unfortunately, the way I just kind of been playing with this a little bit, current output's clear. Oh, come on. Not sure why it's being a little ornery today. All right. So I am going to go ahead and create these things. These are happening in series, of course. And instead, what I'm doing is I'm just saying plot.show after creating each one of my plots. So essentially what this thing is going to do is just going to create a series of plots. So I'm going to go ahead and run this. And it's kind of neat so essentially as time goes, I don't have any labels on here. I should probably put some in sometime. It'll go ahead and create those all in. And then you can just save the files as you need them. And it's going to essentially go through the entire series. And you can see it's starting to dampen because it's essentially heat equation. We all know you got two heat sources along, say, a piece of metal. Take the heat sources away. You have 0 on each side. And sooner or later, the entire heat will be transferred through and go back to a steady state, which is 0. So essentially, we're graphing those. And then each one of these can be downloaded independently. All right, I'm going to go ahead and stop this. And yes, leave that one. And let's go back. All right, so we're essentially created. The next thing I want to show you guys real quick is this library I came across called MPLD3. So essentially what it is, it's an API in Python that merged Matplotlib and D3. So D3 is a really cool JavaScript library or JavaScript document. I think D3 stands for data-driven documents. And essentially what it is, gives you a lot of cool interactive plotting ability. So I was looking at how we can create some interactive plots on a Jupyter hub that runs cleanly, and it gives you a nice environment. This is one of the solutions that I've come across, and actually plays really nicely. Unfortunately, it is right now, as of now, it is not default as part of our Jupyter environment. So what you need to do is you actually need to do a pip install. So to do that, we're going to go to our server. And actually, the slides are wrong. I need to clean these up. If we go to our new terminal, this brings you to a terminal window. Something I also want to show you. This is your current home directory. So anything you do, you actually do need to change. If you want to create any files in your terminal, you actually do need to change the directory to my data. So as we said, this creates so when you launch Jupyter, it creates a Jupyter Notebook instance that is essentially your environment. So you're running as the only user on that environment. Everybody who launches Jupyter has their own session. So everything is being ran under the Jupyter user, which is why, when you go to the terminal, this is what you see running. And it maps, or it mounts your My Data directory to your Jupyter, so you can go in it. It's very important that anything you do in Jupyter, anything you save, any files you write out, go out to the My Data directory, because if they're sitting outside the My Data directory, like I have these two untitled notebooks, those could very well be deleted, destroyed the next time we go through a rebuild. Those are not permanent. So anything you want to create, anything you want to keep, needs to be in that My Data directory. All right. If you need to customize your environment, that's something else to think about, and this is what we're about to do with the MPLD3. We're going to do a pip install, so you have to do pip install -- user, and then the name of the library that you want to install. D3. And, whoops, that's right. So we're taking the MPLD3, which is what we need. MPLD3. It's already installed for me, but those of you guys who want to play with this at home, you're going to need to actually do the pip install -- user. It's going to tell me it's already there. It's going to go and install that for you. Something to note is when you shut your server down, any of these custom modules that you loaded in are going to disappear. So you would have to install that in again next time. Our design team, our developers here are actually working on a solution to that where you can actually customize your environment. That's just not ready for release yet. Okay, so once you have that installed, we can do some fun stuff with it. And you guys may want to go ahead and, yeah, so this is wrong. It should be pip install -- user MPLD3. And I'm just going to look at, this is the GitHub repo where it's sitting at, so you can go ahead and go there and look at their sample code. I went ahead and pulled in one of the pieces of sample code already, their notebook demo, and I'm just going to show that to you guys. All right, so here's a little example they have, and of course, they have a little scatter plot very similar to the one I showed you guys earlier. And problem is that it's not very connected, but they do. If you kind of see how they have it going, it's a little, you can pan, so you can pan our data around in here now. What I really like about it is when you do pan, if you notice, the axes actually move with you. So that's actually kind of slick. You can also zoom in on your data. So if I created a zoom in library, what I really like, the animation on the zooms are actually really, really slick. And like I said, it's actually really simple. So what they did was they created, you did a random number, you created a X and Y, a bunch of random numbers in there. Same thing with color and size, bunch of random numbers in there. We make a scatter plot, and we print that out into a grid. And then they just displayed the figure that they created. All right, and they created, and they can go and see that. All right. They also have other versions in there too. They have a histogram. And once again, that's the same thing. We can zoom in on one particular part of the histogram. We can pan along with it as well. AX.history is what we're creating. We're adding, you can add other subplots to it to set up your grid. We're just doing it with random numbers and how we want this histogram to look. Hitting the home button goes ahead and resets it. And like I said, this is very slick because it actually works in Jupyter Notebook in a very nice fashion. There's a version as well that you can run in a different notebook that this works on a Jupyter Hub. Once again, running Jupyter locally and running Jupyter in this environment, running it locally will actually launch a window, and then you can play with the window, and it gives you a lot more opportunities. Unfortunately, with the Hub, you don't have that ability to launch an external window that is running locally on your machine. So this is really one of the better solutions that I've come across. And of course, you can do some curves and some graphs with that as well. Set up offsets. You can do linked access, so everything is kind of on the same page. So if we do a pan, we're panning all the data points, not just the one subplot. If we're zooming in on something, it'll zoom in on all of our data sets, and the axes maps accordingly. So that's really slick. And then the one last thing we have that I looked at is plugins. So what plugins allow you to do is actually manipulate your graphs on what you want to see. One of the main questions we've always had is, hey, is there a way of interacting with our dots or with our points and being able to zoom in on them? The plugins is what's essentially going to be the answer there. So we can select data in one corner, and you see that it actually selects it all the way across on all your subplots. And it's using their linked brush plugin. So if you have for more information, I would highly suggest checking out that GitHub repo. They have a lot more examples, and they have a great quick start guide. I would love to, like I said, I just came across this recently, and so I want to dig through this a lot more and play with it, and then put up a bunch of sample notebooks on DesignSafe that you guys can then look at and see how I did something. I would like to create that the time step solution and then put an interactive plot with it so we can then zoom in on different parts of that time step solution. As soon as that notebook is ready, I will make a notification on the training channel for the Team Design Safe Slack channel, and you guys will be able to share and view that. Okay, so one of the last things I wanted to cover was this thing called Agave. All right, so Agave is, and it's developed here at TAC, and it's essentially an open source platform as a service solution. All right, the idea is this: we have all these resources sitting here at TAC, everything from our giant clusters to some of our cloud resources, and we're having applications that sit there. And we realize that, you know what, not all of our clients or all of our users are going to be on the command line when they're trying to use our applications. So Ryan Dooley came up with this program called Agave, which is essentially a middleware. It is what is used to launch and queue up applications on our resources through a web interface, or a cloud interface, or from your mobile device or whatever. And does everything. It does everything from authenticating to authorizations, compute your data and report data back and all that fun stuff. Agave is what is behind the scenes of DesignSafe when we're launching any of our applications on in the Discovery Workspace. So if we're to go to the Discovery Workspace, so I'm going to pull up DesignSafe real quick, and not the Slack channel, and go to our research workbench and go to our workspace. Each time we launch any of these applications, there's essentially an Agave job that gets kickstarted, and that is what actually gets that system launched. So we have OpenSeas here, and we give it the inputs, give it the script, runtime, job name, and whatnot, and we hit run. That is what triggers the Agave job to go. So essentially, if Agave is an API, and it is what is being used to get these jobs to launch, that would essentially mean that we can do that same thing using Jupyter. All right? So we can use Agave to launch design-safe applications from inside of Jupyter. So if we did, and essentially how to go about doing this is we can go into our notebook. I'm going to go and create a new one. Python 2. And go ahead and import, oops. I'm going to go ahead and import in that. Once again, Agave, of course, AgaveAPI is included as a default in is already included as a application or as a default module inside of Python, so you just need to import it in. You don't need to pip install it because it's what gets used to run it. Couple little housekeeping things we like to do. So, and then this is where comes in to play at. So things you need to know, these are the list of all the applications that we see in DesignSafe. So in our application bar, we do an apps.list, and this is all the behind the scenes stuff that you can see. It tells you what the app is, what the ID is, what the label is that we see, and so yeah, there's all the apps. So to run a particular job through Agave, we're in a little bit of time, what we need is we need the application ID, all right? So if we look at over here at OpenSeas, we should be able to see the application that we're going to run. Zoomed. All right, so there's, I think that's our ID there. So we get that ID, we go ahead and fill that in. We need the application inputs, just like we do when we're running a job by hand. We need our application inputs, our input directory, what parameters we want to give it, the job description that we want to run, and then a job name, and then we submit it. All right. There is a great example here that Steve Mock, who is the director of the ACI team, has put together on submitting a job using OpenSeas. We're going to go ahead and pull that up, and then we're going to go ahead and walk through it. Since we're running slightly out of time. Yeah, that's why I have it printed on the other one. The other one's right. So, so here's our app that we're running. Steve just wanted to make a note that this ID is wrong, but if you do that call we made, which is ag.apps.list, you'll get the proper ID from here. So here is the application ID. So if you want to, for example, run OpenSeas Docker, there it is. That's the OpenSeas that you will run. This is OpenSeas Express. If you want to run OpenSeas, the single processor or single parallel version of it, go through here, find the app that you're looking for. Here's the multi-parallel version. Here's the ID, and here is, where is it? Where'd it go? I just saw. Oh, here's the single processor version. So you probably want to run that. So that would be your ID that you would therefore put into your code, which is right here. So you add in your app, you add in your app ID, you go ahead and set that. Go ahead and set your inputs. So what your inputs are going to be, where you're going to pull those from. Gives you an example of how you want to do that. You put in your parameters. So here's all the parameters that you essentially you'd use to run it. And job description, set your job up, and then you, let's see, submit your job, which is right here. Submit your job, give me the job description, and it'll go ahead and get into the queue, and then it'll run. So what do we want to do? Why would we want to run these applications from like OpenSeas from Jupyter? It's because some of these input files that you want to create might have to be computed first. So you can use your Jupyter or your Jupyter Python notebook to go ahead and make these input files. These input files then get created. Then you could launch your OpenSeas, and you can use OpenSeas to then pull that input file in, get your description all set, and then run it. And of course, since all these things are set up as tags, you can create these things dynamically. So you dynamically create your job description, dynamically create your input files, and then be able to submit your job. And once your job's submitted, it kind of works the same way. You'll get your job, you'll get your output. The output will put itself in the default directory, and then you can go ahead and look at that file path and pull that information out. All right, so a quick summary. We're using Numpy to build our data sets. We're using Pandas to analyze our data sets and be able to save our data out. We can use Matplotlib to do our animation, all right, view our data. We can then play with our data using an interactive plots using MPLD3, which is kind of a slick little app. Like I said, I will come up with some more sample notebooks for Jupyter that focus in on our community's interest. And then, of course, we can then launch our app, pull everything together, launch our app, and then be able to run all of this inside a Jupyter Notebook. All right, if you guys have any questions, we'll be online here for about another few minutes. But I would love to take the conversation to Slack. I'll be on Slack. I monitor that channel all the time, so I'll be there to answer questions. Our developers will also be there to answer questions, as well as some of the PIs might be on there as well. So feel free to ask questions on there. Use it kind of like it's a communication tool, sort of almost like a forum where you can ask a question and an answer might be provided later. You can go as in depth as you want. If you believe the conversation needs its own channel, you can take it to another channel, or you can just create a thread. We're also available by email, so you can training@DesignSafe-CI.org. And then, of course, you can also fill out a ticket if you go to DesignSafe-CI.org/help/tickets. Of course, thanks to Ellen Rathje, Tim Cockrell, Jamie Paget, and Dan Stanzione. Big, huge thanks to Steve Mock for getting that Agave sample for us, and Joe Stubbs, who's one of the our major developers, and Jose, who's one of our major front-end developers. And of course, Craig Jansen, who's our user experience personnel. That's his expertise. Matt Stelmazik, Hedda, they're our graphic designers, and Junie is one of our other trainers here. I appreciate your all's help. Thank you. All right, if you guys want to know any information, here's the references that I used to build this webinar with. Feel free to look that up for some more information. And I just want to tell you that our next webinar is going to be March 29th from 1 to 3. We're doing interactive plots and data analysis with R, so essentially kind of the same stuff we did, except we're going to do it with R and dig in a little bit more information. Once again, feel free to contact us. There's the information, and of course our Slack channel. So I would say Slack channel will probably be the best way of communicating with us. All right. If you guys have any questions, feel free to ask them. If not, come to our Slack channel and we'll pick up the discussion there. Appreciate all your time. Thank you very much.